Ashata Tutorials TV is live. Ashata Tutorials TV. New. Nope.
Welcome back to our online class. I want to be going through the log notation. As we said earlier, it is from 3 topics. I want to do some basics again. You can still go back. The first logic we had given is that a log without a base is like the log to base 10. Any log without a base is the log to base 10. That is basic 1. Basic 2 is 1. 1 will always pick the base. For example, our base here is 10. Our base here is 10. That means that our base here is 10. So we can simply express 1 as log 10 to base 10. If 1 was existing in a sum with a log for x to base 3 plus 1. 1 in this case will now turn to be log 3 to base 3. We can now just go through some examples to see whether we are able to try this out or whether we are able to try the mathematics out. We can now go through the first. This is for the year 2020. This is a log for the year 2020. It says I have log 9 to base 2 plus log of 5x minus 4 over 2 is equals to what? 7. This sum cannot continue if 7 is not expressed as per the log given. As we can see, it is log to base 2. So we can first change the 7 to be a log something to base 2. How? Log what we don't know to base 2 gives us the 7. Meaning 2 to power 7 will give us the x. We had given this basic on our previous stream. So 2 to power 7 will simply be what? 128. Yeah. So if x is 128, we can simply say 7 will now be log 128 to base 2. Replace that on the sum. I have log 9 to base 2 plus log 5x minus 4 to base 2 is equals to, now this one, replace the 7 with this. Now it will be log 128 to the base 2. To the base 2. A number that exists before the log is simply a number that exists before the log is simply a power of the number. What do I mean? Like a half was existing before the log, so it will simply be a power of 9 plus log 5x minus 4 to the base 2 gives us log 128 to the base 2. We now first tackle this. What is 9 to power half? This simply means square root of 9. And we know the square root of 9 is 3. Now we can rewrite again and say log 3 to base 2 plus log 5x minus 4 to the base 2 is equals to log 128 to the base 2. As you can see, I want to rub on the upper part. As you can see, now all the numbers in the sum have a common base. We can now outdo the common base, whereby a plus will be changed to multiplication, the plus between the logs. What do I mean? For example, here we are going to take the log to base 2 outside. The first number is 3. Plus in log notation represents multiplication. So we multiply it by the 5x minus 4 is equals to log 2 base 2 of what? 128. You can choose to cancel these logs so that it can remain as something doable. This now changes to 3 into 5x minus 4 is equals to 128. When we multiply 3 with 5, we get 15x minus 3 multiplied by 4 will be getting 12 is equals to 128. Good. When a minus crosses an equal sign, it will be changing to plus. So this will now go ahead to 15x is equals to 128 plus 12, which is simply 140. 140. So the 15x will simply be 140. If 15x is equals to 140, we are able to find the value of x by simply dividing both sides with the number before the x, which is 15 by 15. So x becomes by 5 to 8. Yeah. So this becomes 28 over 3 or 9 and 1 over 3 or 9 and 1 over 3. The question was around 3 marks. They were so easy. Let us go to the question from the year 2019. It was 4 marks. It was testing the concept of whether you know how to express a number in terms of logs. It was testing whether you know how to express a number in terms of logs. It says log 7x minus 3 plus 2 log 5 is equals to 2 plus log x plus 3. This is 4 marks 2019. These are the signs I was talking about. The signs that are separating one log and the other. A plus will be representing multiplication, not x. So I said a log without a base is just like writing the log to base 10. Let us see. Log 7x minus 3, no base, so we put our base 10. Why are we including a base? Because we have a number here and it needs to be expressed in terms of logs, a power. We have a 2 before the log 5, so the 2 becomes a power of 5. So this becomes log 5 to power 2 is equal to 2 plus log, all these are base 10, log x plus 3 to the base 10. We cannot outdo log to base 10 because we have a number that is not expressed in terms of log to base something. So let us now change our 2 to be log something to base 10. Log what we don't know to base 10 gives us 2. As I said, the base of the log power this number here gives our unknown. In short, 10 to power 2 gives us y. What is 10 to power 2? Definitely 100. So if y is equals to 100, we can simply now say 2 is equals to what? Log, what is y? 100 to our base 10, to our base 10. So we can go ahead and I don't think there is any need of rubbing there. So we can rewrite our question again, and now it will be log 7x minus 3 to base 10 plus log, what is 5 squared? 5 times 5, which is 25, to the base 10 is equals to, now instead of writing 2, we write now this, log 100 to base 10 plus log x plus 3 to base 10. We can now see all our numbers have log to base 10. So it is now the time to do log to base 10. Log to base 10 of 7x minus 3 plus changes to multiplication multiplied by 25. Why are we not using these signs? I say that the changing only happens for the signs separating the logs. The signs separating the logs. So, of 100 multiplied again, because this is a plus, multiplied by x plus 3. Now we can cancel what seems common. What seems common. Now our new mathematics becomes 25 into 7x minus 3 is equivalent to 100 into x plus 3. Good. Now, I do not have a calculator here. You'll allow me to go through the long way. So, this simply becomes 25 times 7 simply becomes 175x minus 25 times 3 is 75 is equivalent to what? 100x. 100 times 3 plus 300. Why can't we group the like terms together by simply picking 100 to the other side and negative 75 to the other side? Once we get there, it is the high time to realize that a sign of a number always occurs before the number, so that you can know the sign it will get after crossing the other side. Like here, a number without a sign is a positive number. When plus 100 will cross the equal sign, it will change to minus. So this simply becomes 175x minus 100x is equivalent to 300. This is minus. Once it crosses the equal sign, becomes plus. Good. So this simply becomes again 75x is equivalent to what? 375 by 75 by 75. So our x here simply becomes by 75 1 by 75 5. So our number simply becomes, our known simply becomes 5. Imagine all this little calculation here gives you a sure 4 marks. 4 marks. I'm sure you have gotten something. A log without a base is like that log to the base 10. And again, a number that occurs before the log is the power of that log. Now, the sign separating the two logs is what changes. For example, the plus changed to multiplication. If it were a minus, it could simply change to division. And kindly students, note that it is not this sign in between. It is the sign separating the two logs. Not sign of one log. Not a sign of one log. Good. We can simply go now to the question of the year 2020. It says the log notation of the year 2020. 2020. Let us see. The question says, without using mathematical tables or a calculator. So I'm good to go. Without mathematical tables or a calculator, evaluate 5/6 of log 64 to base 10 plus log 50 to base 10 minus 4 log 2 to base 10. This is for the year 2016. 2016. This is my year 2016. Now, as you can see, this question has no unequal sign. That means if you don't know how to express a number in terms of logs, you are unable to get this question. From the look of things, all the numbers have log to base something. So we can simply go ahead and pick this number that is before the log, any number that is before the log to exist as a power. Now that is the first step. It becomes log 64 to base 10, and the 64 has a power of 5/6 plus log 50 to base 10 minus. Now this 4 will be a power of 2. Log 2 to power 4 with a base of 10. Dear learner, when you get to that step, don't panic. First, begin by evaluating each number to get a simpler number. What do I mean? What is 64 to power 5/6? What is 64 to power 5/6? 64 to power 5/6 will simply be 64 to power 5/6 simply becomes the 6th root of 64. Whatever you get there, you power it 5 times. That goes to factorization because no calculator or mathematical table. By 32, by 2, 32, by 2, 16, by 2, 8, by 2, 4, by 2, 2. 6th root means in every 6, pick 1. In every 6, pick 1. So 1, 2, 3, 4, 5, 6. So we can simply say that the 6th root of 64 is 2. Now, this one is the same as 2. What is 2 to power 5? Simply becomes what? 2 to power 5 simply becomes 2 multiplied 5 times. 1, 2, 3, 4, 5. So it is the 32. So instead of writing 64 to power 5/6, we will simply write 32. That is good. That is good. Now again we have 2 to power 4. 1, 2, 3, 4. It is here. 2 to power 4 will be 1, 2, 3, 4. So 2 to power 4 again will be 16. Instead of using all these things, we'll simply use these numbers for the mathematics to seem simpler. Log 64 to power 5/6, you have gotten it is 32 to base 10 plus log 50 to base 10 minus log 2 to power 4 is 16. Have we really replaced accordingly? Good. Log 16 to base 10. To base 10. All the numbers have a similar base. So we can choose to outdo the log. Log to base 10. After removing log to base 10 here, we have remained with 32. Now, a sign comes here. Plus will be representing multiplication. Again, 50. After removing log to base 10, we will remain with 50. Minus represents division. And as I said earlier, let the division exist as a denominator. Okay. Why have we not cancelled the logs? Because there is no equal sign. By 16, 1. By 16, 2. Good. Allow me finish it up here. Up here. Allow me finish it up here. So we now have something which looks like this. Log. What is 2 times 50? 100. log 100 to base 10. Now, from our previous examples, we had done something concerning expressing a number in terms of logs. Now we have the log, but we don't have the number. We simply equate it to y. We said this base to power the number here gives us the number here. In short, what do I mean? 10 to power y is equals to 100. In short, how many times do I multiply 10 to get 100? It will simply be 2 times. So it becomes 10 to power 2. Indices says when bases are the same and separated by equal sign, powers are equal. For example, 10 to power y is equals to 10 to power 2. If powers are equal when the bases are the same and separated by an equal sign, what is the value of y? 2. So, in short, log 100 to base 10 is equals to 2. So, the answer for that question is simply 2. Is simply a 2. Is simply a 2. Now that gave the 3 marks. 3 marks. 3 marks. That gave us 3 marks. 3 marks. That was a KCSE from the year 20, KCSE from the year 2016. Another question from the year 2014. Is a question that says, evaluate for the value of x given log x minus 1 plus 2 is equals to log 3x plus 2 plus log 25. As you can see, I said a log without a number is a log without a base is the log to base 10. Why am I introducing that? Because we have a number here. A number here. So let us rewrite this question. It will be log x minus 1 to base 10 plus 2 is equals to log 3x plus 2 to base 10 plus log 25 to base 10 to base 10. So the question remains, all these numbers are base, and a base, but we have a number here which is bare as no a log or even a base. We can choose to use the log and the base 10 because it is what the others have. Log what we don't know to base 10 gives us a number 2. So as we have said earlier, 10, the base here to power this number gives us the y. What is 10 to power 2? It simply becomes 100. 100. Now you can simply say if y is 100, 2 will now be equal to log 100 to base 10. We go ahead and rewrite this. It will be log x minus 1 to base 10 plus log 100 to base 10 is equals to log 3x plus 2 to base 10 plus log 25 to base 10. Good. Once you have gotten there, the mathematics is done simply because all of them have a similar base. You cannot do the base. Now, let us outdo log to base 10. What do we have here? X minus 1 multiplied. Why multiplied? Because of the plus separating the two logs. Multiplied by 100 is equals to log to base 10 of 3x plus 2 multiplied again by 25. Why multiplied? The addition. We cancel the logs and remain with a simple sum. which says 100 times x giving us 100x minus 100 is equivalent to 75x plus 50. We can choose to take the similar terms on the same side. Once a number without a sign, we have said it is a positive number. Once it crosses the equal sign, it will be a negative, and once the negative 100 crosses the other sign, it will be positive. So it will be 100x minus 75x minus 75x gives us 50. Minus will change to plus 100. So what is 100 minus 75? This simply gives us 25x is equivalent to 150 over 25 over 25. By 25, 1 by 25, 1. Why are we dividing with 25? Because it is the number before the x, and we need to remain with the x. So by 25, 1 by 25, 6. The value of our x simply becomes 6. 6. That is how we have gotten our 3 marks from the KCSE of the year 2014. I can see 2013 again gave us 4 marks. 2013 again gave us 4 marks. 4 marks. So we can go to the KCSE of the year 2013 and you see what is there to be given the 4 marks. Joking with numbers and gaining the marks. Joking with numbers and getting the marks. So 2013 gave us this. 2 log 15 minus log x gives us log 5 plus log x minus 4. X minus 4. Now listen and listen very carefully. Now we are about to skip a step, of which even if we include it, it will just be wasting time. Sababu ni gani? This is log 15, log. All these logs have no bases, and the log without a base is like that log to the base 10. If we continue the mathematics without the base, it is okay because all the numbers have that kind of a log expression. So we can go ahead. If there is any of the logs with a number before it, we put that as a power. Let us see. For example, the first part says 2 log 15. We now write log 15 to power 2 minus log x is equals to log 5 plus log x minus 4. Good. Log x minus 4. What is 15 times 15? This simply gives us around 225. So we simply replace log 225 minus log x is equals to log 5 plus log x minus 4. Log x minus 4. Good. Log x minus 4. Let us outdo log because it is what is common on all the logs. Log into 225. Which sign is here? Minus. Let the other number exist as a denominator. Over x is equals to log 5 multiplied by x minus 4. Good. Cancel logs. Here we have 225 over x. Why am I existing in the division as a denominator? Sababu, you will now be able, the sum will now seem simpler for you that way. It will be less ambiguous. So what is 5 times x? Simply becomes 5x minus 20. Minus 20. Why can't we cross multiply? It simply becomes 225 is equals to, what is x times, let me not assume, 5x minus 20. Good. 225 is equals to x times 5x becomes 5x squared minus, why am I putting a minus there? The sign of x is plus. Plus multiplied by minus gives us an overall minus. 20 times x becomes 20x. Don't cry. Now see what they are giving format here. Pick this number to the other side so that we can generate a quadratic equation. After removing the 225 here will become a 0 is equals to 5x squared minus 20x. A number without a sign is a positive number. Once this plus crosses the equal sign becomes a minus 225. As you can see, all these numbers before their unknowns are a multiple of 5. So we can choose to divide everything by 5. So 5 divided by 5 will be x squared minus 20 divided by 4 will be 20 divided by 5 will be 4x minus 225 divided by 5 will be giving us 45. 45 is equals to 0. This is what we call a quadratic equation. I need two numbers, A and B. When I multiply them, I get what two numbers x and y. For example, when I multiply them, I get what I get after multiplying part A and C. A times C. Part A is 1. What am I talking about part? The number on that part. The number on part A is 1. The number on part C, sign of a number always occur before the number, is negative 45. What is 1 times negative 45? Gives us a negative 45. Good. But again, when I have these two numbers, I get part B. And our part B is negative 4. I need two numbers. When I multiply, I get negative 45. But when I add them, I get negative 4. We can simply go to the multiples of 45. We'll have 45, 1, 15, 3, 9, 5. Between these multiples, which of the two numbers am I able to add and get a difference of 4, or even subtract and get a difference of 4 among them? 45 and 1 have a difference of 44. 15 and 3 have a difference of around 12, and we need 4. 9 minus 5 is 4. But the sign here will matter very much. Which sign should exist on which of the numbers, on which of the two numbers, so that I can add and get negative 4? You'll simply find that it is minus 9 plus 5, giving us the negative 4. So our two numbers become negative 9 plus 5. Negative 9 and plus 5. What are they for? We want to replace them on part B so that we can now finalize our question. Allow me, learner, to finalize the question up here. So our question was x squared minus 4x minus 45 is equals to 0. And we have gotten our two numbers is minus 9, 5. We are going to replace them on part B. Instead of writing minus 4x, we will write minus 9x plus 5x. X squared minus 9x minus 5 plus 5x minus 45 is equals to 0. In every two, pick what is common. Between x squared and 9x, we have x into x squared divided by x, we get x minus 9. The third sign will always repeat itself down here. 1, 2, 3 plus 5x and 45 share 5 into 5x divided by 5 becomes x, minus times plus becomes minus, 45 divided by 5 becomes 9 is equals to 0. Now, what is outside the bracket is x plus 5. Inside the brackets is x minus 9 is equals to 0. We have two answers for the x. One is x plus 5 is equals to 0, meaning x will be, once plus 5 crosses the equal sign becomes minus 5. And again, x minus 9 is equals to 0. Once minus 9 crosses the equal sign, it becomes plus 9. So the two values of x is equal to, x is either negative 5 or positive 9. Or positive 9. Wow, wow. Let me see whether we can still continue doing the questions. On 2012, we had a similar question, singular one that said 2 log x minus log x minus 2 is equals to 2 log 3. Let the numbers before the logs exist as powers. So this becomes log x squared minus log x minus 2 is equals to log 3 to power 2. Good. What is 3 to power 2? 9. So the next time we are dealing with this, we'll just put a 9. Good. So let us have to do logs because all of them have logs. We always use log to base 10 when it is log, bare log without a base, and there is a number. Yeah? X squared minus will exist as a denominator. X minus 2 is equals to log 9. We cancel the logs. The x squared over x minus 2 will simply be equal to 9. Cross multiply, this gives us x squared is equals to 9 times x gives us 9x minus 9 times 2 gives us 18. Another quadratic equation. X squared plus 9 once it crosses the equal sign becomes minus 9x. And then minus 18 once it crosses the equal sign becomes plus 18 is equals to 0. Now here I want two numbers, x and y. When I multiply, I get 1 times 18, which is 18. But when I add them, I get part b, which is negative 9. The numbers will simply be negative 6, negative 3. When you multiply minus 6 and minus 3, we know minus times minus is positive. So we'll simply get 18. And when we add the 2, we'll get the negative 9. Good to go. Instead of writing minus 9x, we'll break it to be minus 6x minus 3x. Let's go. X squared minus 6x minus 3x plus 18 is equals to 0. In every two, what is common? Here it's only the x. X squared divided by x gives us x minus x. 6x divided by x gives us 6. Third sign repeats itself down there. 3x and 18 only share 3 is equals to into 3x divided by 3 gives us the x plus times minus gives us a minus. 18 divided by 3 gives us a 6 is equals to 0. Put what is outside the bracket on its own bracket. X minus 3, x minus 6 is equals to 0. Each part of the equation, of the expression gives us a 0. What do I mean? X minus 3 is equals to 0. Meaning x is equals to 3 because this is a negative. Once it crosses the equal sign, it becomes a positive. Again, x minus 6 is equals to 0. When x crosses the equal sign, now it was negative, it will become positive. So the two values of x is either 3 or 6. That was very simple, and it was even awarded 3 marks. It was even awarded 3 marks. I hope I'm not taking you fast. Once I get to a concept we have not gone through, I'll slow down and make you understand. I'll slow down and make you understand. We are now heading to the KCSE of the year 2012. It says without using a calculator or a mathematics table. Without using a calculator or a mathematics table. Solve the following. Anywhere I feel that I have not taught that, I'll slow down and make sure you understand. So, we have a question from the year 2012. It goes for 3 marks. It says 2 log x to base 10 minus 3 log 2 to base 10 plus log 32 to base 10 is equals to 2. We can even start by writing 2 as a log to base 10. Log what we don't know to base 10 gives us 2. We know 10 to power 2 gives us y. 10 to power 2 is equals to y. Meaning y is equals to 100 because 10 to power 2 is 100. Instead of writing 2, we'll now write log 100 to base 10 to be representing the 2. Let us rewrite the question. Wherever we'll find a number before the log, let's try to express it as a power. So this will be log x squared to base 10 minus log 2 to power 3 to base 10 plus log 32 to base 10 is equals to log 100 to base 10. Now, what is common here? Log to base 10. Let us try as much as we can to express, to do log to base 10. Log to base 10 of what is remaining after removing log to base 10 is x squared. I've said let minus represent a division and let it exist as a denominator all over. After removing log to base 10, we'll be remaining with 2 to power 3. And 2 to power 3 is 2 times 2 times 2, which gives us 8. Plus gives us a multiplication. Log to base 10, after doing that, we will remain with 32. Will be giving us the log to base 10 of 100. We cancel out the log to base 10. By 8, 1. By 8, 4. What is 4 times x squared becomes? 4x squared is equivalent to the 100 over 4 over 4. Our x squared simply becomes 25. To get x, we'll do the square root of x squared, which will also do the square root of 25. The square root cancels the square to remain with x is equals to square root of 25 will be plus or minus 5. Why? When we pick plus 5 times plus 5, we'll be getting 25 because plus times plus is plus. And again, minus 5 times minus 5 will be giving us again 25 because minus times minus gives us a positive. Gives us a positive. Gives us a positive. Good. Now we go on to the question from the year 2008. 2008, 3 marks. But the question, before I even write it, is giving us a sum. It's giving us the concept of 1. I said 1 picks the base. If it is base 10, it becomes log 10 to base 10. Let us see. The question says log 15 minus 5x minus 1 gives us log 3x minus 2. I said a log without a base is the log to base 10. So this becomes log 15 minus 5x to base 10 minus 1 picks this base. So 1 here will be log 10 to base 10 is equals to log 3x minus 2 to base 10. Now the bases are the same. We can outdo the base. Remember 1. 1 is the key thing here. Okay, log to base 10 into 15 minus 5x. 15 minus 5x minus all over 10 is equals to log 3x minus 2 to the base 10. After doing, we now go on and cancel the logs. Remain with something very simple, which says 15 minus 5x over 10 gives us a 3x minus 2. We cross multiply till take us to 15 minus 5x is equivalent to 3x minus 2 multiplied by 10. So the 15 minus 5x will simply be giving us 30x minus 20. 30x minus 20. Let us take what is common on one side. 15 minus 20, once it crosses the equal sign, becomes plus 20. 30x minus 5, once it crosses the equal sign, will be plus 5x. 15 plus 20 takes us to 35 is equals to 30 plus 5 will be giving us 35x. We want the value of the unknown, which is x. We divide by 35 by 35. So our x simply becomes 1. If I was asked to advise somebody who has issues with the log notation, I would simply say that just master the basics. Wherever there is 1, express it as per the base. Wherever there is a number, express the logs to base 10 if there is no log, or even use the log to the base and express the number using that base, as I have shown previously. Let us go on. KCSE from the year 2008 again. These people cried. Paper 2 and paper 1 had logs. Those who never had it cried. Those who never had the understanding felt the pain. Because these are just sure 6 marks that went like that for paper 1 and for paper 2. As we have said, 1 will always pick the base here. So it will be log 10 to base 10. If it were to base 2, one could be log 2 to base 2. Okay. Now this becomes log 3y plus 2 to base 10 minus log 10 to base 10 is equals to log y minus 4 to base 10. So let us outdo log to base 10. Log to base 10 into, after removing log to base 10 here, we simply remain with the 3y plus 2 minus changes to division is equivalent to log to base 10 of y minus 4. What is common on both sides is log to base 10. We cancel. So we remain with something like 3y plus 2 over 10 gives us a y minus 4. We go on and cross multiply. This simply becomes 3y plus 2 is equivalent to 10 into y minus 4. So 3y plus 2 gives us 10y minus 40. Ensure you group similar terms together by ensuring that you group what is common by ensuring that the like terms exist on the same side. By taking this one here and that one on the other side, it will simply be 3y A number without a sign is a positive number. And once a positive crosses an equal sign will be negative. Minus 10y is equals to negative 40 plus 2. Once it crosses the equal sign will be minus 2. 3y plus minus 10y is just like having 3 bob and you owe somebody 10 bob. Once you repay your debt, you will still be owing the person around 7 bob, which is minus 7y, is equivalent to minus 40 minus 2, which is minus 42, over minus 7 over minus 7. That one cancels, so y becomes negative times negative gives us a positive, by 7 1, by 7 6. So the value of y becomes 6. You see, without this concept, you could have gotten your own things and think that you have it right. And if I were you, I would ask for you to master the bases. Now we have come all the way from 2010. We'll now be calling for the bases. And once you master all the basics, you're good to go. All the way from 2020, we have been able to get everything right. Now, we are all the way on the question of the year 2006. The 2006 says, without using mathematical tables or even calculators, evaluate 6 log to base 2 of the third root of 64 plus 10 log to base 3 of the fifth root of 243. Learner, as you can see, this question has no unequal sign. And again, the question has 2 bases. If I were you, I would choose to do the 2 parts separately. I'll treat this as part 1 and this one as part 2. And have a different question that says part 1 plus part 2. So, why can't we do each part separately then finish our question using part 1 plus part 2? Let us go on to the part 1. 6 log to base 2, the third root of 64. Okay. Now, let us begin by taking this to be a power of that. It will be log to power 6. We have been told don't use a calculator or even a mathematical table. Don't use a calculator or even a mathematical table. We have to go all the way to factorization. Okay, 64 by 2 will get 32. By 2 will get 16. By 2 will get 8. By 2 will get 4. 2 and 2. Third cube root means in every 3 pick 1. 2, 2. So the third root of 64 is 4. 2 times 2, which is 4. Now, what is 4 to power 6? 4 to power 6 means 4 times 4 times 4 times 4 times 4. 1, 2, 3, 4, 5, 6. 4 times 4 is 16. Times 4 is okay. Times 4 is 64. 64 times 64 will be taking us to around 4096. 4096. 1, 2, which is 6 carry 1, 25. Yeah. 36 plus 2, 38. It is the 4096 we were talking about. So, instead of now using this thing, we'll now change it to log to base 2 of 4 to power 6. And we have said 4 to power 6 is 4096. So, 4096. The question is almost done on part 1. So, log 4096 to base 2 gives us what we don't know. So 2 to power y is equivalent to 4096. Express 4096 as 2 to power something. Learner, allow me to use what I have here to give how many 2's give us 4096. This is 2 times 2, 2 times 2, 2 times 2, 1, 2, 3. 2 times 2, 2 times 2, 2 times 2. Now let us count all these 2's because the 4's were giving us 4096. How many 2's give 4096? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So instead of writing 4096, you can choose to write 2 to power 12. Good. Now, if, as we said earlier, common bases on indices separated by an equal sign calls for the powers being equal. So the value of y here will be 12. In short, log 4096 to base 2 is 12. Part 1 gives us a 12 as the answer. Why can't we go on and calculate part 2 so that we can add the 2? We can add the 2 because why am I doing it part separately? Because they have different powers. Like this one, 10 log 5 fifth root of 243 to base 3. Good. Let us go on and factorize 243 to get the fifth root. By 3 we get it a 1, by 3 27, by 3 9, 3 and 3. Fifth root means in every 5 pick one. 1, 2, 3, 4, 5. So we can simply say that the fifth root of 243 is 3. Instead of writing this, we can replace it with a 3. So this will be 10 log 3 to base 3. If I were you, I would do this question using 2 methods. Which methods am I talking about? This is giving us 1. I say when the base resembles the number there, it is 1. So log 3 to base 3 is equals to 1. Log 3 to base 3 is equals to 1. 1 times 10 gives us 10. So it will be 10 times 1, giving us 10. Giving us a 10. Or we can simply do it which way? That will be a long way. You can simply pick whatever we have chosen. We have gotten our part 2 as 10. So part 1 plus part 2 will be 12 plus 10, giving us a total of 22. 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 Learner, allow me to do one last question and pause it there. We'll finalize later. We'll finalize the logs later. I'm on the year 2005. It is even giving us 4 marks. And the question is so simple. 2005. 4 marks. I'm sure you are able to tackle this question, even if I leave it for yourself. But I will not allow you to suffer in my presence. So I simply do it for you. X squared minus 9 to base 2 is equals to 3 log 2 to base 2 plus 1. I said 1 will always pick the base. 1 will always pick the base. Which base do we have here? 2. So our 1 will change to be log 2 to base 2. So our 1 will change to be log 2 to base 2. Log x squared minus 9 to the base 2 will now give us log 2 to power 3 to base 2 plus log 2 to base 2. Let us also do log to base 2. Log to base 2 of x squared minus 9 is equals to log 2 base 2 of 2 to power 3 means 2 times 2 times 2, which is 8 times, after ignoring the log 2 base 2 will remain with the 2. We cancel log 2 base 2, it simply remains x squared minus 9 is equals to 16. We pick this to the other side, the minus 9 will change to plus. So x squared becomes 16 plus 9, which is 25. To get x, we'll do the square root of x squared and again do the square root of 25. So our x will simply be plus or minus 5. Plus or minus 5. Thank you for being my esteemed viewers. I hope you have learned something. I'll be continuing the logs from the years 2005 all the way to 1995. I hope we have tried and I hope we can call it a nice session. Goodbye. Let us meet in our next session. Thank you. Mbona hii kitu itoki vile nataka?